Even when a study or an experiment successfully avoids bias, there is still typically an element of variation in the data. Every sample may be slightly different and yield slightly different results. To account for this, researchers calculate and publish what we call a margin of error with their statistics. For instance, our poll shows that 65% of the people will vote for candidate A plus or minus 3%. That plus or minus 3% is what we refer to as a margin of error. Now, the margin of error is used to create something we call a confidence interval. That confidence interval is likely to contain the true population parameter. In other words, for this example up here, we know the sample showed us that 65% of people will vote for candidate A, but the confidence interval will hopefully contain the true percentage of people for all the voters that would actually vote for candidate A. So how we create this confidence interval is we take the statistic we found, 65%, and we add and subtract that margin of error. So we would subtract 3% from 65 to create 62%, and then we would add 3% to 65 to get 68%. And this creates an interval from 62 to 68%. And what we're going to say is that it is likely that the true percentage of people who vote for candidate A is within that interval. So somewhere between 62 and 68%. So likely the true value is in here. Okay. Now, the question you might be asking yourself is, it says likely. Well, how likely? Well, most confidence intervals, a pretty standard level of confidence is what we call 95%. But in terms of what that 95% means, let me explain it with an example. A 95% confidence interval means that if a poll is conducted repeatedly, that the confidence intervals created for 95 out of 100 samples would contain the true population parameter. So in 95 out of 100 intervals you create with this margin of error, you would find that the true value is within that interval. Now that does mean that 5 of those intervals probably won't contain the true population parameter. And there's really no way of knowing which one will and which one won't. So again, we are talking about being confident, not absolutely sure. So we are likely to contain the true population parameter within this confidence interval. But there's still a little portion that we need to recognize that in which the true proportion might not be there. And that's because, again, every sample is going to be slightly different and yield slightly different results. And sometimes just through randomness, those slightly different results may be quite a bit different, or at least more different than what the population would be. Here are a couple of examples involving margin of error. In a survey of 2,035 adults nationwide, 43% said that they view climate change as something that will have a serious impact on them during their lifetime. The margin of error in the survey was plus or minus 4%. Let's determine the confidence interval. So 43% was the sample statistic, and we're going to add and subtract the margin of error from it to create the confidence interval. Generally, we add and subtract that 4% by starting with the subtraction because that gives us the low number. So 43% minus 4% would be 39%. 43 plus 4% would give us the upper bound, which would be 47%. So the idea here is that it's likely that the true percentage of adults who view climate change as something that will have a serious impact on them is somewhere between 39 and 47%. A second example. In a survey of 1,500 people in a particular state, 68% said that they voted in the most recent presidential election with a margin of error of 3%. All right, so let's determine the confidence interval. We would take the statistic, 68%, and add and subtract that 3%. Again, starting with the low number, 68 minus 3 would be 65%. and then adding the 3% to get the high number, that would be 68 plus 3 or 71%. So the idea here is that this confidence interval is giving us a very likely region for the true percentage of people who voted in the most recent presidential election. Now, a follow-up to this, let's say the voting records actually show that only 58% of eligible voters really did vote. That 58% is actually lower than the confidence interval. So it's not in the confidence interval. So this would be my true population parameter is not in the confidence interval. So my question is, does this mean that people in the survey lied? Well, not necessarily. The thing to remember is that these confidence intervals are where we're likely to see the true population parameter, but they don't guarantee that the true population parameter is in them. So a confidence interval isn't a guarantee. That you will have the population parameter in it. So it may be definitely possible here that we got kind of a sample that was a bit unusual, and so its confidence interval did not contain the true percentage of people who voted in the presidential election. So that's definitely possible. It's not very likely, so we would consider it unlikely, but it is possible. So we can't automatically say that there were people who lied. On the other hand, we talked about something called response bias from a perceived lack of anonymity. And if you think about this situation, a lot of people like to say they voted and they want to vote, but maybe on the day of the election, they run out of time or they forget to mail in their ballot. So lots of things can happen, and there may be they may want to, put their best foot forward and try to tell the person, yes, I voted, even though they really didn't. So I could certainly see that it would be possible for there to be some response bias in this survey, just because that people like to say they voted. They think of it as being a good citizen that they voted. And so they may not want to be perceived as someone who's maybe not good. And I put good, I'm saying that kind of in air quotes. They may want to have the person who's collecting the survey results think of them as good citizens in terms of voting and whatnot. So I think there is possibly here some response bias.